Can you solve this multiple choice question from JEE Advanced 2019? If you look at this question, this looks very complex, but if you solve it strategically, it is very easy. And we will first write all the information about alpha and beta from the given equation. We know that alpha plus beta is 1, alpha beta is -1, and alpha minus beta is also required, which is square root of 5. And we also know alpha is equal to 1 plus root 5 by 2, and beta is 1 minus root 5 by 2 because alpha is greater than beta. Now we will start finding an, and we can see that an requires alpha to the power n. To find alpha to the power n, we have to start with alpha, which is 1 plus root 5 by 2, and we have to square it to find alpha square, then cube it. And you can see that this is very complex and this is not the way to go. Therefore, what you do is we try to find an expression for alpha to the power n. So we look at the equation and we can see that alpha square equals to alpha plus 1. So if we multiply one more time, we will have alpha cube equals to alpha square plus alpha. And now you can see there is a pattern. And therefore, we can write alpha to the power n equals to alpha to the power n minus 1 plus alpha to the power n minus 2. And similar expression can be written for beta to the power n. Now that we have all the information, we can start solving our question. Let's look at option A. Option A is the summation of a series which is ai 1 to n. So we will write this. Since alpha minus beta is constant, so we take it out. So we have to find the summation of alpha to the power I minus beta to the power I from 1 to n. And this is nothing but the sum of a power series. Now we can just rearrange this and see what we get. We can just write this expression as alpha to the power n plus 2 and this one as beta to the power n plus 2. And this is it, which is equal to the right hand side. Therefore, option A is correct. Now let's solve option B, which is the sum of infinite series and which is an over 10 to the power n. So I can just write alpha minus beta, which is independent of n, so alpha by 10 to the power n minus beta by 10 to the power n from 1 to infinity. So we have 10 upon 89. Therefore, option B is also correct. Let's check option C. Option C says that Bn is equal to alpha to the power n plus beta to the power n for all n. So we'll start with n equals to 1. N equals to 1 means B1 equals to 1. And right hand side is alpha plus beta, which is also 1. So this is true for n equals to 1. But we have to check for other n. So Bn is an minus 1. I will write it this way. Since alpha minus beta is same, so I will just write it together. Now we have to reduce this right hand side expression in the form of alpha to the power n and beta to the power n. So what we will do, we will take alpha to the power n common from this and this term. So we will left with alpha plus 1 upon alpha. And similarly, we will take beta to the power n common from the other two terms. So we will have this. One way is that we write alpha 1 plus under root 5 by over 2 and then take the LCM and so on. Another way is we try to reduce our time a little bit. And we will write alpha square equals to 1 plus alpha, which is 2 plus alpha upon alpha. And now we put the value of alpha. So we have 5 plus root 5 upon 1 plus root 5, which is under root 5. And similarly, we can find beta plus 1 upon beta. Now we put these values back, and also we know that alpha minus beta is equal to under root 5. So we have Bn equals to under root 5 alpha to the power n minus or minus plus and root 5 beta to the power n upon root 5, which is nothing but alpha to the power n plus beta to the power n, and therefore option C is also correct. Let's move towards option D. Option D is the sum of infinite series, which is bn over 10n. So we can easily find it. Bn is nothing but alpha to the power n, so we can write it like this using option C, right? And then we have to find the sum of two infinite series, which is very easy. Now we can see that 12 by 89 is not equal to 8 by 9, therefore option D is not correct. Another way to check option D is that we can see from the given expression bn is equal to an minus 1 plus an plus 1, and we can write an plus 1 in the form of an, which is an plus an minus 1. So we have an plus 2 an minus 1, and we have to find the sum of this infinite series, which is equal to an upon 10 to the power n plus 2 an upon 1 an minus 1 upon 10 to the power n, and this value we already know from option B, which is 10 over 89, and this value is always greater than 0. Therefore we can say that this series bn upon 10 to the power n will be greater than 10 over 89, and based on this we can reject option D. If you enjoyed this solution, consider subscribing this channel. You can also visit my other videos on quadratic equations